Please say hello to everyone. My name is Alfredo Loro. I am right now in Western Canada. We're almost half a world away. Just so you know how far away we are, it is 7 in the morning here, and I think it's what, 6:30 in the afternoon where you are?
Tamalaya, any some detachable years, Nimilaya, Alfredo Loros years, Tanda, Canada layers, the picture, Tanga, you said the life of what the Mariskas, so we the picture conducts to Checkers in series.
So this talk will go, I think, relatively late into the night for you. So I just want to say I appreciate your interest and your will to hear about these things, and I hope that you will enjoy the subject.
Tanda Chizu Nimbana, Tanda Chiduresha, and Asun the Sobeca Seta Gonda, Chuish Harish, Simbanaya, Chizugi, and it's Tonan, Chichi, Casubeta, Lapidilla Shubata, something the Janya to Otelaya, and it goes to Johnson, sending around something Chiati, Nisula, to a Pentoperio is.
What Dimple and Chad and myself are talking about these days is the science of how things move and why they move the way they do, and how nature tells things how to move.
That Gala Dimple regular chat, and in Aras and Chagachesula and Deshajate, Ranshon Kamgin, you put among Gushu Kandas Jaguars, so Nakutsu Karichin and Gushu Jaguars, Tea Porte, and a Motoji, study Yade, Carsagreta, and you put among Gushu Kandas Jaguar, but that Tita Laya, Ni Ranshon Kamge, that Carsagreta, and you put it on the Google race at Laya, and she condom church or Copanach or Tika, which you met the Jaguars.
The study of how things move is really the foundation of physics, because it is the study of how generally things change with time.
That I'm the book, which you Jetanchi or which you jet the income Saniki Manji Chagiores. Tikarlana, that Tanda digging you book, which you Jatan, take a Carsogoresana, Titu, Chinjuan Rustambalaya, Ning Ubolaya, any Carsogoreta, Jurakandas Dugres, at Tendeshagres.
So the concepts that we learn about in the science of motion are fundamental concepts throughout physics.
Tandaging also a new book, Guchugi Caps Jayagi, Dio Rockasa, the Guchuga Caps Jayagi, and it's Pentum Tanga Tatsu data, and income Seriki Nangeta Manji Shisha Chagres. Nepajatoni, the Chesuti mute Chigudo, Chesuti Nane, Kitchen Samatsu Kudo.
So I will be specifically talking about Newton's laws of motion. I'll tell you a little bit more about Newton in a moment. I think you've already met Newton's first law, and we'll talk about that again later on.
That and Narangi Tiade, Newton, Guchugitantum Kolaya, Tians, Titan Sholaya, Newton Goya. Mutuchigins, and it's so Tanda Newton, Tantin Tambo, Corlache to this Januaries, Chitangula Jansaris, Nistambalaya, and Jes Lion, Tiokoyamoto, Robs Giants.
Yeah, so many people were involved, I think, in the study, the systematic study of how things move, starting about 400 years ago, at least in Western Europe.
That andang azuwing yubung guchu jatang kola takshe da course chikurum tang demba dingzing tang demba ge takshe jiate ane tag nubi euro gan sho sala ya ane ko lu shija chang ngaro tawatin res.
So we will focus on the work of two people who became very famous, an Italian, Galileo Galilei, and an Englishman, Isaac Newton.
That andang azuwing na ne mi ni zunzun chi de tan de shija is ta tambote ane Italy gi mi Galileo Galilei res ane yibati ane inyi gi mi ane Newton Isaac Newton is.
Let me just tell you very briefly about Galileo. Galileo lived, as you can see, late 1500s to early 1600s. He was a very early experimental scientist. One of the great things about Galileo is his very careful, very systematic way of observing, physical experiments, conducting physical experiments.
Nahanda Galileo imbana chitong ngaja ge ta karsu tirap tigin june chitong tija ge tiragong go parta dos chijuresta ko imbana ta nawe ge ngoma ge ta ngachu takche jinyi ge chairu pa ching ba kanshila ko ge ta chechu zo de karesana jing yubo ge gucho che ta ga yubo ge rangshin la ya ani chi dingzu tan ban ba ro goren tang dan be gan ne takshe che la ya pe ga wu chu tin de chires.
Today, scientists are generally very specialized, but in those days, people like Galileo had very wide-ranging interests.
That tinsa imbana sanrupa la chikoge takshe ge te chele te pete ta amuskara tindado ta dingzu kanchkana tali chele inju tinda yores ta ngoma imbana da Galileo ta imbana ko ta karsugre ni mambo chilaya ni kheba imbares.
So he was interested in engineering problems, how to, the strength of materials and things like that. He was also very interested in astronomy, and the whole subject of how things move fascinated him.
Ta korain ba na chi ta chi ka rupi ge ni mampo chi la ya gautan khyo yo pa na ne ta ko chi de ane nga chu engineering se ro zoting ge ni na ne ka nyok se thala pe ga yo is ta picha sha pa na de kapsa chi ngi bo chi la peche tang pa ba na ngi bo de ge ne shu ka chu chi thag do ka chu thag mu do sa chi go ra ta ngi bo de ge ta ko ge jippi gi pika chi go ra chi chala zo pa ba na de ge Jerome Dangsa Marela Sopashi Kayat Shikuge, Linechi Chosari Marela Sopage, Tazuchin Nitang Kanyo Sayache, and it turning out to the Kercher Pache, Nature Tanging you boom Gutsuchilaya Pego your response.
He's shown in this picture here, holding in his right hand, he's holding a telescope. Galileo, we should say, built and used the first telescope ever.
Tatanda dig Parnane Kugalapa Ivana Sonsha thing as with Jangshe Jangla Tagichorwa, what it is, telescope race. That dignane ko that Jangshet is Sartochini Dambote Kore and Jangshet is Sartochini, Jangshe Peshutam de Tayanko, Tashiton, Takshin and Dambotem Pichagores.
So because he was a very careful experimenter and also a very rigorous logical thinker, he was able to discover things that went against what people believed at the time.
다 거기 코인바이나 딱시지야다 고 딱시 심직지야 기바체 대강라야 준천양 고 준천 시 프로콜라 텐데된 거기다 그거 니도 mam보직 설니 종어와 디 설니 종요레스 임바이나 거기 설니 종주데 간자 네데 뒤갑대기 아니 지금 집단 그 용차부 예체당 아니 갔대당 야나 잠게도 차요레스
Notably, Galileo showed that the Earth and all other planets revolved around the sun.
다 그 지까지 요래서나 스콜라 당자크 참마 사게 쳔바 다 제구디 바이나 니말라 쿠라자가 요파티 요레스
Yeah. I'll talk a little bit later about one specific experiment, a very simple but very important experiment that Galileo did. But we'll talk about that later.
다 제슬라야 아니 갈릴레오게 트립샤주 딱체 게 쳔부치 무추치기스
And this is Isaac Newton. He's an Englishman. You'll notice that Newton is born in 1642. Newton is born the year that Galileo dies. So Newton is one generation after Galileo.
다 신다티카레스네 뉴턴 레스 뉴턴 임바이나 고 지야데 직동 투자 신이도 왔고 시비글로데라야 갈릴레오 중글로데 치바차도 와데스타발라야 아니 뉴턴 데 갈릴레오레 머럽치기 제라 총지레스
Newton was also a very careful and very good experimental scientist, but he is mostly known as a mathematician and a mathematical physicist.
다 직동이 바나 코이 뉴턴 바이나 양아 좀 유게 다치카서 그래 알아 딱시지하게 딱시게 산류밖에 전부치레스 임바나 띠나네 그 묵색이 바이나 다 앙츠로 앙츠라 옆에 키바체 아니 앙츠탄 데비게 인칸 루팔라야 아니 페 키바텐레스
In mechanics, specifically, Newton wanted to solve the problem of how the planets and other solar system bodies move.
다 하버드 단단가 쪽에 구시루파기나네 아니 뉴턴게 가리 탑시당 요레세나 아니 ngacho ta nyimi chinjinang ga zakar tang ta ti parnana yo pegi nyubote tang guchu kandas chi yo pegi guchu chitang kolaya tasechi yodes.
Okay, so that's a little bit of history. And so let me now tell you about what these gentlemen did.
다 때 로지 가서 그래다 통통 지체 다 단단가 속에 네 그속에 지가리 드립 메테 모트치기스
Just to give you an idea of how important their discoveries and their ideas were, even today, I'll just point out the fact that we are so far away. You are in India, I'm in Canada. And the reason why we are able to talk today is because I'm generating some electric signals that go up to some satellites orbiting around the Earth very far in space. And these signals then are transmitted back to India and ultimately reach you.
단다 되게 갑성이 나동 같이 무트 진이죠 바디카리인세나 근데 단다게 니캅텔라야 나라인 바나 캐나다라 예스니 제수인 바나 자갈라 요레스 다 단다 나는 것도 스케자 셰피 값스 게자 셰페 데이터 아니 록달라 주데티 고 가리 땅고 요레세나 아니 고 바나나 요피게 코르케나양 코도 스탕고 요레스 딱 코르케테 다양 고 바나네다 고 스콜라라 두스코라자고 요로와 콜라 땅 고기 땅주데 아니 양체 최소 사마라 땅데데 최소 사다 tin jorgo yores instambalaya nga su tela tenideti banana yopi korkete tala tenideti nga su pertharan pu yopa imbaina ya hansulaya ni kecheshege ni tande yongo yores.
This is pretty amazing if you think about it. And it begs the question, well, how did those satellites get to where they are? How did those satellites go into orbit around the Earth.
That dene dandage ni tandela samuchi tambana nguni yan sambure doas. That detan dressing at trust tanga karyore sana skola ge ane ko korlang banala ya kura japunu korkrech goro ta mizu shaju kokya tangsa ju goro daya matanya. Kusu tanda US netela ya kanas cleveres.
Well, the engineers and scientists who let's put it this way, designed the trajectory of those satellites. In other words, the engineers and scientists who said we should launch this rocket in this direction at this time, they're using essentially the same ideas that we're going to be talking about that Galileo and Newton discovered.
Nahanta tandage korker mezu korker is a panang la tangya ge kapsarwa tangwe kapsata tineg and it's Henry Pata Tiorwa, Tinreg, Henry Pata, that Tinreg, Zutin Power Kutsuge, that Korkaya Tangvi Kapsatang, Suge, music Sunkerti Tangi or but they Tangi Kaps, the Mishukundagi Tangi or what, they Tangi Kaps, and it should send Delaya, and a cookar secret, said Tinder Rochi, you send them Rochi, Gani Tamba in Bina, and you co such a doachilaya, do slag do say, get you or what, but Tina tea, and Karesena, that Tandangatsu Zentanang, Junction Baggy, and income Senric and the Gushugi, and Chimchigorwa, on data, Natsuga Junction Bandeta, and it Senripata Zutin Kusugi, Pecho Tang Deti, and you Tanda Cocker data, and you column la legacy or is.
All right. So to begin at the beginning, I just want to review some important concepts that you've already heard about. But just so we are clear on what they mean, we're going to be using these concepts a lot. So to begin with, what we mean by the position of an object. I'm only talking about motion along a line for now. I'm not talking generally about motion in 3 dimensions.
That under the capsule, and Gushutan Devi Karsugre to get him catching Mutuchi instead they chicken get Karsugre and Gushutan Devi, Neton Kanza capsule, the Takachim which are in race. That the capsule, Tamputing Asukaris and Nishi said it is, you put a coach like you may say, and Nisatan Nishi said it is. Netanda and Gushun the capsule, Asukan Deshajan, the capsule, Gushu said, and the Katila, what Tangtich Ganlan Dushin Big. Ani Karsubrin Gushuti or Mutuchi Stim saying the Mato, ni Chose Sumga Gangla Yasgur, that Chose Suntan then begin Gushuganabati, Deshijag Maze.
So let's say that I want to tell you where I want you to put an object, say a ball, along a line.
That under the caption Narangi Chetsula Shedikan is a Chetsula Polo Chirua, and it's Tangtich Jut, Puluchi, Nishikola, Shame Kumutuchi, Shagumi Kumutuchi is.
So we divide the line into, length units.
That under the caption Atsuge, that teacher or a titi, a caricio is and a titi Gosha Jasha, Gosha Kagina Gosha Jayorisena. Then
I can say to you, for example, please put the red ball 3 units to the right of that black dot.
That ko tindachinu jelangi kalagores and Chetsula, and under the polo marble day, and it's not pushed away. Or dene, and echo that's some gets hamla. Some gets hamla and a shock of some samla sharochilagis.
Or I can say to you, please put the blue ball 2 units to the left of the black dot.
That's in the Gasanagrace, Napolo Mombote, and it's an apotege, Yun shock is hamlaya, Yun shock salaya, and it's the Shinig samla sharochilagis.
Yeah, so the black dot, we can call that a reference point. We position the balls to the right or to the left and a certain distance from that reference point. That's the black dot.
단단하게 값은 속에 차나 보치도가 차나 보들라야 가지고 뒤시세 그래서 뒤시로 뒤서 뛴적 시사지와 뒤서 뛴적 샤사 뒤시제 뒤시딜라 때네데 아니 코에 동아예 아니 코 가서 그랬다 지시 가서 진두고 메로와 파주살라니나 수미나 가서 임바나 뒤시 샤사게 뒤시데 아니 차나 보들이스.
And then notice that I need to give you two pieces of information. I need to tell you how far the ball is from that black dot and in which direction, left or right.
단단하게 값은 임바나 가서 니치슬라 니츠니 쿠토시요레스 치카레스나 볼로데 차나 보데네 니 잔타 가서질도 스로아 지제 니바데 가르스나 카쇼콜라도 스로아 일라도에 연라도스.
Yeah, so those two pieces of information together are the position of the ball, or the position of the object.
단다게 차트 니츠 데 니샤게 아니 볼로데게 니시 가이메데 아니 모토치그레스.
Next up is the velocity. And the velocity, what the velocity is if the ball is moving, by how much does its position change during a given time interval?
다티기 제라야 셴다치가레스나 뉴르세레스 다 뉴르세티임바나 지가서다 주체디 주라도데로아 아티기 준두기 트라야 아니 유보티기 니시라야 아니 주란도세데 가서치레세티 라야 뉴르세세그레스.
Changing position, because remember, position was distance from the reference point and direction, those two bits of information together. In the same way, the velocity also contains two bits of information: the speed, how fast the object is moving, and in which direction.
한테다나 담보텔랑아서 니시게 계지시면 스tambalaya 니시텔라야 고 차팅 니상고도와 시가레스나 고 뒤실리로와 뒤시 뒤서 뛴주고 니데레 천하고데스 거라 뒤실리 아니 장세 가서실도 세 직제녀데 카쇼콜도 세 저와 데 인샤상고라 띠나시 네 뉴르셀라야 고 가리상고레스나 적세당 가쇼인샤상고요레스 적세세나 적셀랍나 니부데 아니 고 졸로도도 세 저와 티리스 아니 셴다야 카쇼콜도 세 되게 차트 인샤상고요레스.
So, for example, let's say that the red ball was 2 units to the right of the reference point, and then it moved in 1 second. It moved another 2 minutes to the 2 units to the right.
다 비차샤바이나로 불로 마포데 토마 아니고 천나포데레 다 뒤시레 지시니가 참라요레스와 아니 가샤시게 제라야 티니 양체 지시니라야 바 침바레스.
So now, and I will say this slowly because the wording is important here. Sorry. There we go. The ball moved at a rate of 2 units per second. That's the speed. To the right, that is the direction of the velocity.
다단다데 값에 지금서 네츠니시오레스 다 당보드칼라나 볼로데 가르차치기나 텔레콤바 니도도 세테기 가르텐 거레스나 그건 적세테 땡기요레스 아니 드에테 예쇼살로도 세테기 가르텐 거레스나 카쇼 땡고요레스 다텐시 냠트 마수기 뉴세세테 크로치레스.
So again, 2 bits of information. How fast was it moving? 2 units per second. And in which direction? To the right in this case.
다단다데 값에 양치 절대 제바이마이나 마서 라 차트니요레스 치가레스나 볼로데 니 졸로도도 적서 가서도도 스컬처 가서 가차치나라 가서도도 적세 치기체 니바텔라야 아니 카쇼콜라도도 다 단단데게 네 타임바나 예쇼살라도도 세 때 니차게 차트니차 니 냠트 요레스.
So what can we do with the information that the velocity gives us? If I know where the object, the moving object is right now, what is its position right now, and we know by how much its position is changing each second, then we can tell where the object is going to be 1 second from now.
Nitsu data ngatsu kari chit kres na roa ani tanda roa keti ngatsu ge yubo chike ani nyurse ha kwa che roa nyurse ha kwa sana ko ne khasho kwa la ya ne kachare re na la ya ne janta kasu stu du sa ne tante ha kwa che de gan la ya yubo de ge thomi ge ne shi roa thomi ge ne shi te ha kwa imbai na ani ngatsu kari ha kut kres na yubo de ani ta karchach ke jela ani nishi koala hemingi netante nengatsugi shet grace.
So this is a very important idea, that the velocity, which is a change in position, allows me to tell where a moving object will be at a later time. We will come back to this idea shortly.
That tandage netante keshin bushu chagres ro di karchilla ba na nyubo chi netan chi la yo because nyubo tege ta nyurses gro ko culture re na tele katsuchi drugo do se tege ani ko culture chi ge jela nyubo te ko chi la hem lege netante ngatsu lo ko chi gres te keshin bu chagres ta te ngatsu ge na chongchang de jela ya na chi motor chi yes.
Okay, and the third concept that we need to be aware of is the acceleration. The acceleration, just like the velocity is a change in position over an interval of time, the acceleration is a change in velocity over an interval of time.
That ngala nga su ge nyurse tong song wi ga ni tanda nyunnon se te yang ka re sena ni duyin shikana la ya ni nyurse la song wi ge jurala ku yo res.
So again, the acceleration has two bits of information. One is the size of the acceleration, and the other one is the direction of the acceleration.
Ta yang de la yang ngoma ta chong ba ta nyunna la yang ko ngoma ta chong wa ko la ya chati ni yo res ro chati ni yo ba de ka res na ching bor se res chi chong ka chu tu se de res ni wa de ka sho res sho ko la du tu se de res.
So the acceleration tells us the change in velocity. So if the acceleration is in the same direction as the velocity, that means that the speed of the object is increasing. The object is speeding up.
Tatanda dege nyunnon ta ane nyurse ni ge khasho ta nyunnon ge khasho te nyurse ge khasho ta chupa imbai na ane tege kare songore sana nyubo de ane ko drusa ge khasho te la jinjuk srugo yo pa songores.
And as you can imagine, if the acceleration is in the opposite direction to the velocity, then the object is slowing down.
Tate nanshingi ro te ta ane karsa te nanshingi shenda chi karo esne ke te nyunnon te ane nyurse ge khasho ta doba imbai na chungu me ba imbai na te kare songore esne nyubo te jida te rugo yo pa songores.
So I don't know how you translate the word acceleration into Tibetan, but in English, it's unfortunately the everyday meaning of the word acceleration is to speed up. But in physics, it has a much more general meaning. Acceleration can mean speeding up, it can be slowing down, it can mean changing direction, quite simply. It is a change in velocity. So it can be any change in velocity.
Yeah, that's true, because the Tibetan term, we just directly translate the English term as acceleration, like increasing velocity. So yeah. Also, like we have the other term like deceleration, we have the decrease in acceleration. So
yeah, exactly.
But under the capsula, so I think did it. Checking banana so the set the acceleration say in Chigla Taba in Bana and a couldn't Mampuchila land you start Pukina Canado Jurio Mehakuma, so start another Supokina Pena Juredic Neton Taba in Bina, and co Tandaku, Tondo Mampuchi Queen and Gichiga Mashipu and Wangas when you're none less Tamba, you'd say Jinjo Duarwa. This number last Chitang Asugi. You know, say acceleration say in Chigitsky, Chitango Kualantain by Nata, and come Tanito Mando, Chitango Kualan by Lantain Bina, could you set the Jinjos Duala Kugurista, Jinjos Duala Kuguris. In by nine, you come Tandican on the Kualan by Bina, you know, said acceleration said Sidegi, you set the Jinjos Duala Songre, you set the Jital Duala Songre, the Nansing Casual Duayon Songuris.
I want to be very clear about this because we're going to be using the word acceleration a lot. So acceleration will always mean any change in velocity over an interval of time, not just speeding up.
The shape where the Junsen Koreans and Natsuki Tsidi, you say acceleration say, you say Tsidi, and Mambutangaris, that the Kapsin Bana Koga Kuati. And you said the Jinjos Ruat Samana Kugo Maris, Roa Kogeta, you say the Jinjos Ruatan Kugomaris, Nursela, Jura Chimba Zankogoris, Tati, Jura Nan and Jura Rotamampuch or one, Smithua, the Kangi and Kuyores.
Okay, so armed with those three concepts, the idea of position, velocity, which is changing position over an interval of time, and acceleration, which is a change in velocity over an interval of time. Now let me talk about Galileo's very famous but very simple inclined plane experiment.
Tatandanga sugi Tatsusina degree Kutote Sunching de Orwa Nishi Senacare is what the name you say Senacare, you know Senacare is Teta Gi Guati and some like me with Tony Tandanga su Galileo ge Aneko Tati Karsugre Delaya Sangwi Chidwa, Salam Chidwa, Ti Pechutang de and you bogie Gushulaya, Takshe, Chilgin Bana Tab Duchiris, Tepo Canas Drio Mekola Deshagians.
So I'll tell you what Galileo was looking for. He was interested in this case in what we call free fall, which is simply that, you know, if you take an object and you let it go, and it falls to the ground. And obviously, since it starts from rest, it accelerates to the ground, towards the ground as well.
Tatanda de Capsuco, Taco Galileo Coranchi to Nochi Satan Corange, Jusuo, Lotte Sato Carisena, Nubo, Tangasuge, Round Home Satiris, Round Home Nubola Taxichetris, the Round Home Nubola Taxi Round Home Sena Carsuresena, Chonogin Nubochi, Talapanaya Songarwa, Lapana Zon de Dancomal Hontuba in Binas, Kumal Hontuba in Bana, Tomadelaya Kugin Yursele Corwa, Conguchetango Marwa, Lapanaman Home, that home along the Samdela, that home Badanko, Sagusolaman Drugo, Remission to Sagamal Hungary, Salamal Home Pigita, Home Rintelaya. No Kuranga Nursete any Jinjon Dunita, you not in your race.
So Galileo wanted to measure the acceleration. He wanted to measure by how much its velocity changed per second as it fell to the ground.
Galileo Kuranga Carita Sichin to Paris, Stambalaco, Nubote Satola Maral Hombi, Capsua, and a Kugin, your second Joan Rotanroa. Now there
was a problem, and that is that the free fall happens too fast.
Tatelaya Kangechures, Karekangures is tumbling a butch around Honchi Pambana or Kumal Honchi Pambana, Penjopus Hungiorwa.
So you release a ball, and boom, it's down at the ground in less than a second, and you haven't had time to measure anything.
Like a channel Puluchidus Sala Hongachi Bana, Pulute Labana Leba, Kerchili Nuaga, the Sala Sadik Yorwati, Randelaya, and Chorolaya, Tejai, cook up the Yomaris, Chitsuyo Maris.
So we found this way of slowing it down by, instead of dropping it vertically, letting an object, a little ball in this case, go down a gentle slope.
Takuga ngibuti ko khatma longbi jiba tig chavlaya ku kare chigoresna tate jopo songuyoro takshiti jopo chonguyoro ta ku takshiti jidala taige takshi chinye yores ta jidala taide kare chigoresna tandang ta polo te ko sangwe chilaya ane dus ta ku mangkure karso sangwe tin mangkure long chibares tatiga tele sangwe te yang ko jambo re to.
So he was good with his hands. He didn't build this one that you're seeing in the picture. This is a replica, but he built one exactly like this.
Can you repeat that again? You cut off.
So this is a replica of the inclined plane that Galileo built. Okay, so I want to show you now a little video of what this motion looks like. And what I would like you to think about while you watch this very short, very silly little video is I would like you to think about how realistic does it look? Okay, so I'm going to stop sharing for a second, and then I'll start sharing another window here. Okay, so here we go. All right, so there's I hope you can all see this. There's a little ramp.
Yes.
Yeah, just like Galileo built, and there's a little ball at the top, and we'll let the ball go down.
Galileo
let me show that to you one more time. So the ball starts from rest, right? So its velocity is 0 initially. And so the ball will be speeding up as it goes to down the ramp. It has an acceleration down the ramp. Okay, here we go. So see, it's speeding up. Yeah. Okay, so let me stop sharing that again. And let me just put this one to one side. And I'll go back to my slides. Okay, so you've probably never seen a ball going down a ramp, but I think that you will agree with me that that looked pretty realistic. So the reason why I'm showing you this is to point out that if the animation is realistic, then we must be doing something right. If we understand how the animation was made, then we will be able to understand more about how things move in the real world.
Tatandagi gunyentiwa, gunyenti ene ko ngumata wichila na yo paimbaina ate karsugre ta korangi gunyenti ko chitang ta ne khabartang guchuge chitang ka namba te chiwarwa ate chi tatak dege yo pa ane chongu yores ta ketinga sugerwa ketinga su gunyengi zu chiwarwa gunyen zu gunyen zu te koranga hakwa imbaina na ngasuge tela tende de tanya ngasuga ngyo suwitu guchuge koro hachang ngachu good grace.
So let me tell you a little bit about how these animations are made.
Hanta tanda ngasuge ching gunyente kanado zugu yomege ne taching otochigins.
First of all, when we see an animation, we see it because we're playing a trick on the brain.
Tanda ngasuge gunyente na do thong bi kapsa ngasuge thong ngasuge chimiki na tele ngoya chora gunyente gujim begin nyela ya na ngor wande karla baina dela ya nenga suga lepi na la ta trick less tambala ta yushis na dukore ta ko gokortang ye nang sachi dela ya peshetang yores.
So an animation like this is made by showing pictures, different pictures, very quickly, one after the other.
Tanda diredo ge gunyende karichore sena ngatsula ya Pershi ro Pershi kachi and chikijile chichi jopoten yores.
When we see a picture, when we see anything, what is happening is that the light from outside enters into the eye, is recorded, let's say, by nerve cells in the eye, and this is interpreted by the brain as an image.
Tanga suge Pershi ro Pershi karichi me tombi kapsim bana Pershi tini chong waiting at suge and it me jichi to or muji drus tambalaya, me nana yo pigit and make a javolo yo pigit, no one such has it jijete go that thing also lepala tong lepaganing as to carry tongu yo metela ya kogi, the karsu quati language.
And then that image fades away, it disappears, so that we can see the next image.
That andage lepanana kualenju which karsuka the perchi or rata nangyenti and it meperchak or stick jelaya, tigi jima per jima thing as res.
This takes time. It's a small fraction of a second, but still it takes time.
That Goya ko Kerchagi that you Bumbo Hachon Chonchumashi Gogumaris, Imbaina Yantina no Joelati Sungogioris.
If we're looking at something that is moving, the next image will be a little bit different.
The getting a suing you which in Guchutanga do say again, not the Tabaimana, Neko Kapchik Tamagi, Jetaran Laya, Kachik Jetaran Laya, Nangasu Tonated is Mandojiris.
So here are several pictures of a man riding a horse, and you can see that each picture is a little bit different from the previous one. The horse's legs in particular are at slightly different positions.
Tatanda de Kapsimbana party takares and a michi tala shumbi partina redus, Roatan and the per tamputitan Nuatan Sumbadusanga Durba in Baina, Nipper Guramishinta. And a perganana, this mando theories that support any tag not so come by or take Koganisatan Kogite, this mandores.
Now, here's the thing. If I show you these pictures very quickly, one after the other, the brain sees the object as moving.
De carriores and de capsing ye at the per data or per data chicky jela chiti jopotembaina and a lepagi carindo which qualangres and as well lepa canadroach tungre lepa canadroach la qualangres and you put in guchutango pigam ola qualangres.
So this is what you see in this little box in this image where you're seeing all of these pictures one after the other very quickly, and we think that we're seeing a man riding a horse galloping along.
That and the Ganga you pick a part the tongue as Chiki Jela Chidus 10 by Bana, Joput 10 by Bana, Hatsugo Etige, Isurgo, Matela, Michitagan, like a Shunju at Chidua. Or that part of those Chijela Chidus 10 by Bana, Hatsu Lepaga Karitungres, and Miti Tagan Lashon that the Jiguyo Pachitungres.
Okay, so in the animation that I showed you, it was really a series of pictures, one after the other, at a rate of 60 pictures each second.
That tiga ngela yang asu chitan soya gunin chitan soya. Dia Canada yore sana yang ko muni nanjin tunggu yore simbai na yang dia kare sana per mampu chikijila chitan jutin yore chikijila chitan yang ko teng in preset yang kare sana karcha chikanatele per tuchi thamba tinda ten yuge netan chag yore.
That's too fast for the brain to see the picture separately, and so you see the ball rolling down the incline, and you see the little airplane flying through the sky, and they seem to be moving.
That take a reason to take up the hatch and chopo tangy years and also a big party thought to come about Matuache, anything Gushatango Patungo, Chesuga Polo, the somewhere in the third man could change on the way patan, Nam teaching little dorsals to your paton.
Okay, so my job in building this animation is to tell the computer where to draw the ball in each picture.
That and I tell and Gunyan de Chawachi Tan Sumi Gane, Tangarangi Karchigresina, any Lolelaya, any co per reganalaya, Polote call a Trigumen Gita, condom teachigres.
In other words, I need to tell the ball, to tell the computer what the ball's position should be in each picture.
That in a season that you share by Bana Karisugresana, Ni Lolaya, Kariga condom chigresana, per reganalaya, ne Polo de Nishi Kari Yemente Pandesijaguires.
In this case, the position is given by the distance of the ball to the top of the ramp and the direction from the top of the ramp. So the ball in this case always moves to the right, let's say, and the reference point is simply the top of the ramp.
That and then the Nishi in the Shajan Stambala or Nishi de Shajan Stambalaya, Copolo de Tampo, and a song with a Semola Yopi Capsuqual and Guata, and a co with Drusag Cashote, and a Tanda song with Trusagrota, Tanda de Capsemana, Cashoa Tayan Tabana, Yeshola Tagio, the Decapsimbana, and so the Tampo. Tomagi to Shishagoro, Kawala Timiki Bese, to Shiti, the Capsimbana, Samugi Timothy Winzungu.
Okay, so how do I do that? Well, I certainly have to tell the computer where to put the ball initially.
Ta Karichiguresana, Tambotelaya, ni Lolelaya, Karideshaguresana, Polote Toma Kola Jagu, Meti Condom Chiburis.
So there's an instruction to begin with that says, draw the ball at the reference point, draw the ball at the top of the ramp.
Ta Karichiguresana, Polote, Tomaroa, Toma Polote, Nishi Gala Sharochis, Nishmas, the Tishi Gala Sharochis, the Tishi and the Take a solemn dig, Zimoder, what the Sharochis Tribures.
So that's easy, but how do I tell the computer where to draw the ball in each successive picture?
that the Tambutita Lila would was. And I take a jelaya, roa, take a jelaya, and I take a jela on big ne parity kanalaya, and a polity call a cheese, ne canasla would is.
So you remember what the velocity was. The velocity is the change in position of an object over a certain interval of time.
The other dinisha to near the correct tangures and nurses at the tangures. Nurseti carisena polo, the Nupochi banning Ubote, and it doing Nichaganalaya, and you could Nishila and Jurakanda to make it.
And I mentioned that I could use the velocity to, given the position of the ball now, I can use the velocity to tell what the new position of the ball will be in the next picture.
That under Tampo initiative Haku, Tinekolaya, and Josete Haku by Bana, or Nurseti Haku by Bana, and I take Jedelaya, and a Pershing Yibangalaya, Pulu and Nisa Kairi, but this is at Cures.
So let's say that in one particular picture, the ball is where it's drawn here.
The Paring Chikanalaya, Puluti Tanda Nisadela Paimana.
And I also know the velocity of the ball at that point. So maybe the velocity is, I don't know, I'm going to make up a number, 10 units to the right. 10 units to the right per unit of time. So if I take as my unit of time, the time between two pictures, then the velocity is so many units to the right per unit of time, but over the time that it takes from one picture to the next. Now, so remember, I was showing the pictures at a rate of 60 pictures each second. So the time between two pictures is 1/60th of a second.
Per mando anigi parola ngoya tuchute karesena karcha chigdi tumbu tuchla tang bicha chigtang chagores.
Yeah, so the velocity of the ball could be 10 units to the right in 1/60th of a second.
That under take a politic and josete karesena koge chok kashote ishosalache and it's the city to jute and it doing gasolan goresena karchage tuchichage chingoriores.
So the computer knows that it will have to draw the ball 10 units to the right in the next 1/60th of a second. So 10 units to the right in the next picture.
That means Tambala Netontilatene and Lolaga Kariha Kuresna, Kap Jimatilla, per Jimatinalaya, Nick Karcha Karsugata, Karcha, Tuchichag chicken alaya, Polote, and Nico Karsuga, Samla, Tribu, Metihakuris.
Okay, so that's easy. I tell the computer, first of all, where to put the ball in the very first picture, and then the velocity will tell the computer where to draw the ball in the next picture, and then in the next picture, and then the next picture, and so forth.
That little chag was Tampoting Polote Tampo Karsure. Tampote Polote Timotila Shagu Genetante Desijasona, and take Jelaya, Nurselatinity, and then Lolegi Polo, Nipper Jimatina Kawashagi, Tigi Jimana Kawashagi, Tigi Jimana Kawalegi, and then Lolegi curious.
But there's a problem, and that is that the velocity itself is changing.
다 단단히 단데 값을 강해지요레스. 가리 강해요레스나 디게 값을 뉴스 코로나인 바나 지원도요레스.
So let me just go back here. What that means is that I also have to tell the computer how the velocity itself is changing. So I have to tell the computer the acceleration of the ball.
That is Dambalaya de Galarwa, Kunsela Jurandugo Yazangi, Lolelaya, and a Nurse Kuranlaya, Jurandugo Yopigin, Tante, Lolelaya, and Deshijabu. This Dambalaya de Capsa, and a Nunon Chungopa, Polo Tingusitan wake ups, Nunon Tabi Yopigin, Tante, and a Lolela Labures.
So here's what the instructions for the computer look like.
That is Dambalaya, Masuga, that Lolelaya Koshichi Rock, Lolela Condom Chichibu, Rachivi, Caps, any co Geta Karsukoch, the Canalochi, Mende, Tilaya Tensha, yes.
I should mention before we go through this, what a computer can and cannot do on its own. Computer is very good at doing math. It can do multiplications, divisions, additions, subtractions, all kinds of mathematical operations.
The condition Major Gala Yang is Shenda Karsula Lolegi, Karichi, Pumatikane, Tante Desijagins, the Loleti in Bina computer, Loleti in Bina for the answer on the oil you get Sita Karijago Bina Yang for a Pekiva Yoris, the Pichashan and Jurgo Chilasopa, Zijala Kiba Yoris.
So I need to tell the computer two different things. I need to tell the computer how to calculate, for example, how to calculate velocities and positions from the acceleration.
The picture Shana Chikarioresana, Nuna Latinidati, Nutsetan, Ni sheets, Zijagchigachigaro, or Tian Alaman Chorus.
But I also need to give the computer some numbers to work with, and that's the other kind of information that I need to give it. So in this case, I'm going to start by telling the computer, look, for all the pictures, the acceleration is the same, and I give it the value of the acceleration.
Pershi Tamagnani, Nunti, Chimbalaya, Zigu, Shipaimbala, Zigu, yes, Lindeshiti Jati, and then Yunun Karim by the Trankatia, Putochiguris.
And I emphasize the word assume because the acceleration doesn't need to be the same all the way. So this is an assumption.
The caps Zigu said, I am a Chanjochi, or Nunti, Imbala Chanjochi, Imbala Zigu, Yores, Nikado, the Tayores, Lola, Roti, Laviores, the caps, Yan Chanjochi, Diana, Zigu said, the kitchen which I was. Yunun Sama, Katimbana, Yunun Sama, Chipaim Batina, Yomaris.
It's a crucial assumption, and this is in fact what Galileo found with his actual experiment.
Tako de yang kechambu chagunu ga jinsen chanjok de kechambu chagunu ga jinsen ka rese stambalaya ane de kechambu chagunu ga jinsen ka rese na Galileo kurangi takshet ti chiwala tene dete nyenun ti chi tsungimba de nyebares.
Now the second thing that I need to tell the computer is what to do about the very first picture, because there's no picture before that it can use information to decide where to put the ball. It's the very first picture.
That take jela ya lola la kare desi jagores na pari tampo tigna la ya pulu kola shagu yo meni suti kula lola la desi jagu yo esti kachila ba na pari tampo tige nge la ya ko ya shisha sa ko parti yo marwa ins tambala ya tampo tila ya pulu te ani kola drugu yo me ne suti lola la khotruchi gu yo res.
I could tell the computer to draw the ball anywhere along the ramp. I choose to draw it at the top of the ramp. That's a choice.
Nati jela ya ane shirgi imbana polo dirwa ta saglam tege ni gawala tina dhikuyores imbana ya tanda dela ya saglam tege zimola triya de dam yus tati imbana dela damka ge nansu chiyong ngoyos.
And in the same way, I could choose to give the ball any velocity I want. I could make it so that initially it's actually moving downhill. I could make it that initially it's moving uphill.
Taya di nanshingi karsugure nirche tiya karitenet kores ta tampo imbana polo te tanda saglam tege ngola ma dhugo yopagi tesha yorwa di nanshingi ane nirche chikere ta polo te saglam tege ngola ya dhubige tena tenand kores.
So again, I choose to put the ball at the top of the ramp and to give it a velocity of 0, so that the very first picture, the ball has no velocity at all.
That is tambala tanda thela ya karichi suyore karichi dam yore sana pari tampo tignala ya polo te salam te simula shagi bata ne tig kapsa ne polo te gume imba kola nyutse me pa le kro imba ge ne suti do so te lola la kotu chi ba te dam yes.
So in the second picture, because the velocity was 0 in the first picture, it's still drawn in the same position. But in the second picture, by the second picture, its velocity will have changed because the acceleration makes it change.
Per niba te na la ya ku ge nyursela jro to go yores karchin la ba na ku ge tela nyunon te yo ro nyunon te yo so nyunon te la ten de ta nyursela jro to gres.
So we use the velocity to determine the ball's position in the next picture, and we use the acceleration to determine the ball's velocity in the next picture.
Ta nga su ge per tangpu ta per segura ta nibo ta da polo te gi jose peche tang de te ane polo te gi kasa polo te gi jose peche tang de tang per jima te gi na la yo pi polo te gi nishi te ane che tenke chi ache ne polo te gi nyurno peche tang de tang per niba te na la yo pi polo te gi nyurse te tenke chi wa chigres.
And so now we have the ball's position and velocity, and we can do this all over again. We can use the velocity again to determine the position in the next picture, and we can use the acceleration to determine the velocity in the next picture.
That na shinga sulang yu butigi ni shi da ta nyurse istambala ya nga su parsure ta nyurse te peche tang de ta parshima te na ne polo te gi ni shi da ne nyunon te peche tang de ta parshima na ge ane nyurse te tenket gores.
And so on for each successive picture.
Ta par jima te tak na la ta chik jela yo pe par te tak na la ya ne de gana yo pe gi kurim te tak pe chitang de ta ne met te chinan degrees.
So you remember that I said at the beginning I had to tell the computer 2 different things. One was I had to give it some numbers to begin with, and the other is how to calculate the position and the velocity from the acceleration. So I had to tell the computer the acceleration.
Ta tambo de la ya kasogre lole la ya kutuchi gwa ge ni tu kashi chores ta tambo de bana ane lole la ya zijaga yu chugi zijaga chi te tangka kachi anki kachi yang kutuchi gu yores ro niba de la ya ane ku zijaga chi ro zijaga de ane nga su kasogre nyunno la tene de ti ane nyurse ta nyurse la tene de te ni shi zijaga chi ro otigi ko zijaga te pa de shi jagu yores.
Of all of this, the most important instruction that I give the computer is the acceleration. What is the acceleration? I told the computer the acceleration is the same all the time, all the way down the ramp. And I've given the computer the actual value of the acceleration. so many units of length per second.
Aha. Tadanda kapsa Loglala ya condom chichior or coach chichior or coach condom chiwati nani ke chishiti kare sana ane nyunun chioro nyunun di tako kacha tata chashi yang shige re la ya ani nyunun katsun dugu yomegi ne tante ke chishiti chagis.
So once I tell the computer what the acceleration is and where to put the ball to begin with, that's all it needs to know. Then the computer happily does all the calculations.
Tanirwa tadagi ngarangi ani loglela yata kondom kochi nani nyunang kari imbata tampun district gudwa nyunang kari imbati te tege chela ya thumate polo tela ya nishi ti motor chipaina ani logle khorang ngone sijabde tan tege chima la ko imbate ne logle ngone gaga tutu ngone sijayong res.
Computers work very fast, so the computer will create all the pictures, many pictures, hundreds, perhaps thousands of pictures very quickly.
This tabla ya legi aniko tandaga parshi teta tun tabla hachan joko gane tin gores. Chichina pari tonta chitinda tonta tinda ko joko tin gores.
Okay, so let me show you another video. I'm going to have to, this will take me a minute. I apologize for the delay. I'll give you a little break while I bring this up.
Sure. Tatanda nga sugi yang lognin tong jenda chiktengi yens tela ko teaching gorsari teaching groshi sa.
Okay, so this one's going to be a bit different. So there's a ball on the ground here, and you have to imagine that somebody is kicking the ball straight up.
Tatanda di ngogeti ta this tag mares ta de kapsi chezu kari chila karimba chachana degrees na fulode tampo ani tangla yo bache ani me chiki ya tangsho sa ro ya gentle tangja shwa chila kwala na degrees.
So let's look at the motion. This motion will be a little bit more complicated than the previous one. It'll be a little bit more interesting. Let's see how this works.
Tatanda di ngochote ngoma ngochota ko testa nyokta sayo res simbana nga su de kanado chindu bin tagos.
So there we go. That was let me show that to you again. Show that to you again. Okay, here we go. So the ball will go straight up, but remember, the acceleration generally is downwards. So think about
yang chistang is tada de kapsi samna ngi gwa te nga su gi nyenon chi ro nyenon ti chitang chane imbaina dinado ne tang kapsi ro chitang chane nyenon ti ani thul to shoyo patingi bures.
So the ball is initially kicked upwards, so the acceleration is in the opposite direction to the velocity. And that means, remember, that means that it will slow down. And in fact, that's what it does. And it slows down up to a point where it's actually not moving for an instant at the top. And then it starts going down again, and now the acceleration is in the same direction as the velocity. So now it will speed up.
You pick up and polo ya to your and unity ko dosota tula stambalaya and also unity and your segi kashota doa in stambala ko chita to chita do that ni parka chilaya ko stimula happy parka tilaya poluting gumelaya ko choose chilaya gochomechu nibola chigre tenekuma stambalaya and ko Mayungura, Mayon Stambalaya, Nursayam, Marche, Tulache, and then Unity Tula Stambalaya, which in John Lewis.
Okay, here we go. So you see, it goes to the top, and then each time it bounces back, but it does essentially the same thing.
Then the Rela, the Tanchipardo, ya, Chita do, Ganado, the March in Johnson Salasa, and Checo to Staco, Passion to Chigua, Chungodoa.
Okay, so back to my slides again. Yeah, so the acceleration is again downwards, and here's a picture that shows the whole process. So I've made the ball go a little bit sideways so you can see what's going on. Otherwise, we wouldn't be able to see the motion.
Remove Karsa Polo this pass are you Nathan Galaten, this Tambala, Nathan Tongo, Timenda, Katu Yado, Katu Mayon by Naya, very goni, Kawachidua.
Yeah, so initially it's moving upwards, the velocity points upwards, but the acceleration points downwards. So it is, like I said, it's slowing down.
On the
way down, the velocity points downwards, and the acceleration is always the same, so it also points downwards. So it's speeding up.
The matro yung pickups new city to la shore
So on the way up, for example, if I look at two successive positions of the ball, you see that, for example, here, the two positions differ by a lot, whereas here, the two positions differ by much less. The time between two positions in this picture is the same.
In Tanda Digi, Persian Dina Yopi, Capsura, Ulugi, Nishi, Mando, and Yig, Parogi, and Goyagi to search your race.
So if the change in position between these two balls is smaller than the change in position between these two, in the same amount of time, that means that the ball up here is moving more slowly than down here.
Tana big polo nigi, that nation nigga paroge, Jansete, all your people nigga Jansele, Nishi nigga Jansele, Choy, but the Choy race, in by now Kungoyate to swing the Chupachingo, Chitan, take a caritango sena, and a Tana Yopigi, that Pulugi, Nishi nigi, Paro, that take capsugi, Nutsete, and all your piggy, Pulugi Nation, Nathan take a capsule, your piggy.
So that's how we can tell in this picture that the ball is slowing down or speeding up on the other side.
That the Latin de thing also person the Latin de polo de ya chita to your pattern and it my own stambala ya chinjo do your pagi. It something also dig on me decision grace.
And you'll notice in particular that at the very top, right up here, the ball actually stops. It is neither going up or down.
That Tanda Chesu do not chong actually, Karituno chong ta ako similar stambalawa to shetila pickups polo ti chusam chilaya ko gusam jokuyores wa take ups polo ya do yomar ma do yomares take ups any gushu mepi in nivala degrees.
That only happens for an instant.
Tandaga netanti chusam rangla chongres.
That does not mean that the acceleration is zero. The acceleration is always the same.
Chutam chilaya kung gusumepala some shocker than gumegi nebala degrada, Natilatini de mendu segio mares, one meba de sanguio marin, katim by naya, flash of the race.
The velocity is zero, but not the acceleration.
Take up Sukuge, Nursete lecores, Nunen lecormares.
Okay, so again, I keep repeating this because this is really important. If the acceleration is in the same direction as the velocity, the ball goes faster, and if it's in the opposite direction of the velocity, the ball goes slower. Okay, so we come now to a couple of big questions. And this is the whole reason why I've been showing you these little animations.
Data tenguege ikarsabare tachula ngala gujik khachi tenswa tati tengunu gu jinsen ke choten deres.
So just to summarize again, what information does the ball need to know how to move? And I'll let you think about this question for a moment. If you would like to talk to the person next to you and see if you agree, what information does the ball need to know in order to know how to move?
And the college to the China to do young Chetuge, Ropan, Lamochina to what. Polo tigi korang gusho kandas jagures gucho jatan te shiala ya polo te korang la ya nitsu kare gugures chatan kare kugures.
Go ahead and think about that for a minute or two.
Te kola ya karma chitan kama ni rang la ya samlutan roches ropa parola keche shenan digres.
Okay, so you probably agreed that what the information that is needed here is what is the initial position and velocity, and what is the acceleration at all times, which we assumed was always the same.
chesuge samare de kile chiyo chires tomatela ya ko thomege neshi tan yoseje ani timse ani tikap chamage kapsu politiki nyunnon ha ko res.
So the next big question is, who tells the ball what the acceleration is? And the answer to that is very simple. I do.
Ani draw nibate kare sena polo tela ya nyunnon katso yementi sundeshi jagre sena ati lilores ting yendeshi chi yores.
Now, you may think that's a silly question. Of course, I tell the ball, or the computer in this case, what the acceleration is. But there's a reason why I asked this silly question. And I'm going to ask an equally silly question after that, which is, how does the ball get this information? And the answer to that is, well, I give the computer instructions.
Teaching is to draw the cancer, chop to chomechu draw in the sangre, Simbanaya, taking Yunotic Chambucha, Pulo de la Yunokare Yementi, the Sugadeshi Jagares, nothing Arangadeshi Jagodes. That draw data on Chitsungagane, Polo de la Tinado, Chatanti, Canado Chitoguresena, and any Lolela Tikosu Kutuchevares, need Lolela the Kutucherwa. And then I do chigur is content and then lole take to pulu kola you made to thank you or what.
Now, the reason for these silly questions is that I'm going to ask exactly the same questions next, but thinking about the real world and the real experiment. And yeah.
Tandagi draw that chomechi draw Sakura, that chomechi draw Tinado Tangun Jinsakari in Sanangi draw Taranja Yanshi, this Jela Tangi, this Jela Tangayati, Matsugi, Nyogi, Netanta, Ranshunga Kamgi, Nyogi Netan La Shisha, that draw the Yanshi Tangians.
So in the real world, and I'm not going to do it here, but you can imagine I have a ball in my hand and I have an inclined plane, and I release the ball. What information does the ball need to know in order how to move? Who tells the ball what the acceleration is? And how does the ball get this information in the real physical world?
Tanga chu ngye chua tang ngye ge rong shong kam ge ne sila shisha ji de chua de tang bai bai na ro ta chorong ge kar chi go re sena chorong ge tanda saglam chi ke ngwe la ya pulo chi dus ta ko de chi chi go re pulo chi man ko du chi ko res ta te kap su de la ya ne pulo ko rong tin man ko gu chu ta ya la xia la ya ko la chatrin kare gu go res wa ane ko pulo te la ya nyonon kare yementi ko la ya pulo te la ya su de shi ja res. And
I didn't plan this, but this brings us almost exactly to the end of our first lecture. So I won't tell you what the answer is. You'll have to come back in about half an hour, and we'll try and answer those questions.
Tanda tichula pinch tata roching as Lesha, standing in the draw data kill, tanda kutuchi mes, Chesuge, ni Samutangajes, Yanshangas zombie capsa, ni drug landy carry metagins.
Okay, so let's take a little break at this point. My understanding, am I right?